This is a recap of the first quiz we took this unit from 9192. I know some of you have had some questions about some of the solutions, and so just wanted to take an opportunity to go through each problem, and maybe this will help you understand so that you can prepare for your upcoming assessments. So these may not be in the order that you did them. This is the order we created them, and then it jumbles it up when you guys take it. So just look in your notes that you took as you were taking this quiz. Try to line it up. So the first question that I have here is tell whether each situation is describing a permutation or combination. Then find how many possible situations could occur. So remember, permutation, order matters, combination doesn't make any difference. So here we have, out of a student body of 100 students, a president, vice president, and treasurer are chosen. So our first answer for this is going to be a permutation. Because it does make a difference how you choose those, because those are three distinct offices, so to speak, for the student body. They're different from each other, so it matters what order you pick them. If you pick the president then can't be the vice president, so order does matter. Permutation, so then what I'm going to do is I'm going to go here and go 100, and I'm going to pick 3. And that gives me 970,200. And on the quiz, it did say not to put commas in there. And some of you didn't see that. For Mr. Rutherford's class, I did go back in and adjust those. So it didn't count off on your score. Just make sure you read those directions before you start any quiz. Okay, let's move on to the next one. Tell whether each situation is a permutation or combination. So we have Lizzie is going on spring break. She has 18 shirts in her closet, but can only pick 7 to bring on vacation. Now, it doesn't mention anything about picking any order. It doesn't matter when she picks one shirt versus another shirt. So this here is going to be a combination. This makes no difference if she chooses her red shirt and then her blue shirt, or a blue shirt and then red shirt. And it says that we have 18 of them, and we're going to choose 7. Let me throw that in there. We get 31,824 combinations there. Tell whether it's a permutation combination again. How many situations? It says Adam, Caitlin, and Brooke run a 5-mile race. How many different ways could they finish? Now, it's not saying first, second, and third place or anything like that. It just, how many different ways can they finish? So this is also going to be a combination. Doesn't make any difference what order they finish. And so we're going to go 3, choose 3, because there's 3 runners. There's 3 different places. And when you do that, you're just going to get 6 there. Find the number of distinguishable permutations that can be made from the letters in the word Germany. Okay, so for a problem like this, we need to first analyze, are there any repeating letters there, and there aren't. And so as a result, we're just going to go 7 factorial. And that's going to give you 5,040. But in this next problem, you'll notice that you've got a couple letters that are repeated. Okay, so let's highlight those. So you've got the P doesn't repeat at all, but you've got the R that does. You've got another E, and you've got an S. It's going to happen again. So if you count those up, you're going to find that you've got 13 letters total. So that would be 13 factorial if they were all unique, but they're not. So we're going to divide out those because they each occur twice. Those 3 letters, you'll divide by 2 factorial times 2 factorial times 2 factorial, which really is equal to 6. So you're doing 13 factorial, essentially, divided by 6, because 2 factorial is equal to 2. Okay, so we end up getting 778,377,000 600 different permutations for that. Okay, yes, this is the one that was so challenging for most of us, and it is a bit abstract. So let's take a look. How many code words of any length can be spelled out using game tiles of 5 different letters, including single letter code words? Okay, so the first thing to keep in mind is that we are using letters. That's true. But what a lot of you thought we would do is use somehow the number 26. But really, you've got there's different ways to look at this problem, but you've got 2 different ways. There's these 5 different slots. So you're either picking a letter or not picking a letter. Those are sort of your 2 options. So yes, I'm going to pick a letter, or no. Well, that's 2 different possibilities. So for this first slot here, we can say yes or no. For the second slot, we can say yes or no. Same for the third, same for the fourth, same for the fifth. Now, that'll give us, if we do 2 to the fifth, we end up getting 32. But here's the problem. If we say no to all of them, there won't be a code at all. So what we have to do is subtract out that one time where we would say no to every single one of those. And so really we have 31 different possibilities there. Now the other way you can do this is you can use combinations. So I can take in my calculator, and some of you used permutations for this. And you can go with, so we've got a total of 5. So we can go 5, choose 5. Oops. And then we would go plus 5, choose 4. Plus 5, choose 3. Plus 5, choose 2. Plus 5, that was a big 5, sorry. 5, choose 1, and you will get the same thing, 31. So I know that one was a tricky one. There was one like it in the homework. Let's go ahead and move on to the next problem. How many 5 character code words are there if the first character is always a letter? Okay, so 5, let me just get these different. So 1, 2, 3, 4, and 5. Okay, so 5 characters. First one's a letter. Okay, we know there's 26 letters in the alphabet. And the other characters are letters and or numbers, but there's no repeats. The fact that there's no repeats is important because you're going to have a decreasing amount of possibilities as you choose these letters or numbers. Okay, so since we've chosen a letter in this first slot, that means we're going to have 25 letters for the second slot, and then we're going to have numbers 0 through 9, which is 10 numbers. So you're going to have 35 different possible things we can choose, either letters or numbers there. But then one of those either letters or numbers has been chosen. It doesn't matter which has been chosen. We just know that one has been chosen. So now we have 34. So it could have been a letter. And if it was a letter, that's fine. We'd have 24 plus 10. Still 34. Or if it was a number, it'd be 25 plus 9, still 34. And then we've taken 2 of them out. Now, 2 more, or 1 more, I should say. And so now we have 33. And then finally, we would have 32. And so when you multiply those out, you get 32,672,000, and then 640. Find the coefficient of the third term in the expansion of x minus 2 to the 11th. Okay, so you're going to have to work out Pascal's triangle pretty far, and maybe you searched it and found that on the internet or something like that, and that's fine. But I'm just going to go ahead and write out that 11th row of Pascal's triangle. So it goes like this: 1, 11, 55, 165, 330, and I'm just going to stop there and just say this is going to keep going, right? So I'm looking for the third term. So I'm looking for this 55. That's going to be my coefficient at the beginning, but it's going to be a multiplier. So I need to multiply that by what I find from this. Now, the thing to keep in mind is because we're on the third coefficient, remember how we have these decreasing. And so you're going to end up with this as 55 times, so the x, I should say the x exponents are going to decrease. The negative 2 exponents increase. So you're going to have, this is going to be times x to the 9th times negative 2 to the 2nd. Remember, these exponents always have to add up to 11. So negative 2 to the 2nd is 4. So we have 55 times 4. X to the 9 would be our whole term. We only are looking for the coefficient, so I really just need 55 times 4. But our term would be 220 x to the 9th. My coefficient is 220, so my final answer is 220. Find the coefficient of the 6th term in the expansion 2x plus y to the 8th. Okay, so again, we got to look at this 8th row of that Pascal's triangle. And so I'm going to go ahead and start writing that out. I need the 6th term, so let's go ahead and at least get to that. So I've got 1, 8, 28, 56, 70, 56, 28. Let's go ahead and write all of them out. 8 and 1. I want the 6th term. That's the 56. So then as a result, you think about down here, you know, your x is going to be to the 8th power, and your y would be to the 0 power. So I'm going to decrease with the x's. So 7, 6, 5, 4, 3. So I'm going to be to the 3rd. But don't forget, you got the 2. It's a 2x to the 3rd. So I'm going to put that in parentheses like so. And then I'm also going to have that y, and then 3 plus 5, of course, is 8. And then don't forget the 56. So the way that this is going to work is I'm going to have 56 times 2x to the 3rd, and then times y to the 5th. I'm looking just for the coefficient, so I'm going to go ahead and put the whole term, and then we'll just, you know, write that at the end. But I've got 56 times 8, x to the 3rd, y to the 5th. And then we have 56 times 8, which is going to be the key here. And 56 times 8 is 448. So our term is 448, x to the 3rd, y to the 5th, but I want just the 448. So my answer is 448. Okay, let's go to the next one. This is expand 3x squared plus 1 to the 5th. Okay, so let's go ahead and write out our Pascal's 5th row. I'll have 1, 5, 10, 10, 5, and uno. And then I'm just going to go ahead and start dropping things in right below. So I've got my 2 terms, which are 3x squared, and then the 1. So I'm going to go here, 3x squared, and that one will be to the 5th. And then I'll have 1 to the 0. And then I've got the 5. So that's going to be 3x squared to the 4th, because I'm going to decrease. And then this will be 1 to the 1st. So that doesn't look like a 0 there. That's a 0. I'm running out of room here. Okay. So then for the 10, we're going to have 3x squared to the 3rd, 1 to the 2nd. And then for the other 10, you're going to have 3x squared to the 2nd, 1 to the 3rd, and 3x squared, this will be to the 1st, and then 1 to the fourth. And then finally 3x squared to the 0, 1 to the fifth. Okay, so let's go ahead and let's figure these out here. So we've got, in this first situation, we've got 1 times 3 to the fifth times 1 to the 0 times x squared, essentially. Instead of writing all that out, I'm just going to kind of verbalize that. And that's going to end up giving me just 3 to the fifth. So we've got 243, and that would be x, and we'll have to the 10th because we'll do the 2 times the 5. Okay, so next one, 5 times 3 to the fourth. The last is going to always be 1, so we don't really need to worry about that till the very end. So in other words, 5 times 3 to the fourth is going to give me 405, and then I'll have 2 times 4, which is 8, so x to the 8th. Now I'll go 10 times 3 to the third. So 10 times 3 to the third is going to give me 270. And we'll have x to the 6th. And then we've got another 10, so 10 times 3 to the second, and that's going to give me 90, of course. So 90, x to the 4th. Then we've got 5 times 3, which gives me 15, and I'll just have an x squared. And finally, at the end, you're going to have 1, well, 3 to the 0, that's 1, times 1 to the fifth. So we finally get to use that 1 at the end and put a plus 1. So you're just supposed to fill in the blanks, the correct blanks there, but that's the entire answer there, okay? Let's do one more expansion. This one is a fun one, of course. Nice and challenging, a lot of things going on. And a lot of you did very well on this. There was just one little thing I'll mention here in a few minutes that was the most common mistake for my students, and may have been the same for Mrs. Hilvert. So I'm going to go ahead and list out that 7th row of Pascal's triangle. So I've got 1, 7, 21, 35, 35, 21, 7, and 1. And let's go ahead and now we got our terms, which are 2x and -3. Here's what I'm going to do. I'm going to rewrite this as 2x plus -3 to the 7th, just to remind ourselves that that's a -3, not a 3. And now I'll go ahead and fill in the terms like I've done before. So I'll have this 2x, this will be to the 7th, and then I'll have -3 to the 0. And then for the next one, we've got 2x to the 6th, and then we have -3 to the 1st, 2x to the 5th, -3 to the 2nd, 2x to the 4th, -3 to the 3rd. Again, always checking that my exponents add up to 7. 2x to the 3rd, -3 to the 4th, 2x, sorry, that's an email, to the 2nd, -3 to the 5th, 2x to the 1st, -3 to the 6th, and finally 2x to the 0, and -3 to the 7th, or 7th if you are French. Okay, so so in this first one we're going to go 1, I don't know what that was, 1 times 2 to the 7th times -3 to the 0. So 2 to the 7th is 128, so it's really 128. And then we'll have x to the 7th. And this next one's where most of the mistakes came in. So you have 7 times 2 to the 6th, 7 times 2 to the 6th, times -3 to the 1st. Well, -3 to the 1st is negative, so this should have been a minus 1344, which would make it plus a negative. So in the blank it had, or on the outside of the blank it had a plus, and then you need to put a negative on there. You know, just a small little detail, but just one point there. And then we go to the next one. We'll have 21 times 2 to the 5th times 9. which will give us 6,048x to the fifth. And we've got 35 times 2 to the fourth times, that would be negative 3 to the third, negative 27. So then we end up getting negative, or I could put plus and negative. I can't remember what blanks we had to put in there. So 1,000 or 15,000, excuse me, 120, and we've got x to the fourth, and 35 times 2 to the third times negative 3 to the fourth. That's going to be a positive because negative 3 to the fourth is positive, and we get 22,680 x to the third. I'm running out of room. I'm going to put it down here, plus, and we'll get a negative on this next one. 21 times 2 to the second times negative 3 to the fifth. I've got negative 20,412. And that's x to the second. And then we've got 7 times 2 to the first times negative 3 to the sixth. And I'm getting a positive 10,206. And that should be x to the first. And then we do basically just negative 3 to the seventh at the end, which will be a negative. I'll put plus a negative because, again, I don't remember how exactly we had it for our blanks there. So, but again, the big mistake for my students was this negative right there. Okay, other than that, pretty good job on that problem. So I hope this really helped you out as you prepare. We'll have our 9.3 through 9.5 quiz this week, but then as you prepare, to finish up the unit in a couple of weeks, you'll want to make sure that you have this. And I know it's been challenging to not be able to ask us questions in person or us go over quizzes and things like that. So I hope this really helps out a lot. Feel free to reach out to us with any more questions that you have, though. We would be glad to answer those. Have a great day.